So let's use these rules and the advanced rules. So let's suppose that we did not have a rule for tangent. So in our basic rules on the left, we do have a rule for tangent, right? The derivative of tangent of x with respect to x is secant squared of x. So let's actually verify that rule. Now I can also write derivatives like this. I can also write d dx tan x. Now you should understand that d dx is not a fraction, right? This is not, you can't cancel these d's. The d dx, the whole thing is one symbol, and it's a symbol that means it means take the derivative of the thing that follows with respect to x, right? It actually tells you the variable. So the derivative we want is x. Or sorry, the variable we want is x, and we're taking one derivative. If I wanted two derivatives, I would have had, say, d2 dx2. If I wanted three derivatives, I would have had d3 dx3. Okay, so verify that the derivative of tangent of x is secant squared of x using the other rules. Okay. So looking at our basic table and our advanced table, right? How might you think? So again, suppose that the rule for tangent of x is taken out, right? Suppose that's not there anymore. How would you go about finding the derivative of tangent of x using the rules that remain? How do you think we might combine them? Again, tangent of x does not appear here, but tangent of x can be gotten by combining some of these rules together. So I can use quotient rule. So Justin says I can use quotient rule. And why is that? Because tangent of x is the same thing as sine of x divided by cosine of x, right? So and I have a rule for sine of x and cosine of x. Okay. So that's what we're going to do. So we use quotient rule. Okay. So the derivative of tangent of x, I'm really writing it as the derivative of sine of x divided by cosine of x. And now I need a stencil for quotient rule, right? So now this is something you've memorized, or you will have memorized. So the stencil for quotient rule, it is a quotient, right? I do not just take the derivative of the top and bottom separately, right? I do not just do derivative of numerator divided by derivative of denominator, right? That's incorrect. Okay, so the stencil for quotient rule. So first of all, let me call, so sine of x is like f, and cosine of x is like g, right? This is like f over g, right? So I'm using, let me just scroll up. I'm using quotient rule. That was that last rule, the less advanced rule in that box. Okay, and then the stencil is, okay, the derivative becomes, the denominator is g squared, and then the top has this kind of stencil, right? It's a product of two things minus a product of two things. And what are those things? It's f prime g minus f g prime. Okay, so now it's a matter of just filling in this table. Or filling in the stencil, rather, using the table. So f prime, so that would be the derivative of sine of x. And what's the derivative of sine of x? So very quickly, so who's got it? Caleb, derivative of sine of x? Cosine of x? Camelia got it, never mind. Cosine of x, good. And then we have times g, so that's times another cosine of x, then minus f, which is sine of x, and then I have g prime, which is derivative of cosine of x, negative sine of x, good. And make sure you actually have a parentheses here, right? If you don't have these parentheses, right, if I was to write something like that, that's wrong, right? That's subtracting sine of x twice, but it's supposed to be multiplication here. And then the bottom just gets squared, so just get cosine squared in the denominator. Now, hopefully, I mean, we're done with the derivatives, right? The calculus is done. Hopefully, this just simplifies to secant squared, right? That's usually how we memorize this. So let's just see what happens. So the numerator simplifies to cosine squared of x plus sine squared of x, right? The two minuses, all over cosine squared. And we know from basic trig that what? Cosine squared plus sine squared of x is 1. and 1 over cosine, that is what secant is. So in fact, we do recover our formula for tangent, for the derivative of tangent of x, which is secant squared. Okay. Good.